Question says that a cylindrical piece of cork of density of base area density rho of base area A and height h floats on a liquid of density rho L. The cork is depressed slightly and then released. Show that the cork oscillates up and down in simple harmonic motion with a time period of 2 pi root under rho h divided by rho Lg, where rho is the density of the cork, and ignore damping due to viscosity of the liquid. So the case here is, let us assume that this is a beaker in which water is filled, and here is a cork and it is submerged to some level, and it is slightly depressed, and when it reverts back, when the force is removed, then it oscillates up and down in simple harmonic motion. We have to ignore here the damping due to viscosity of the liquid, that is, we have to ignore any damping force that will stop the oscillation, and we have to show that the time period of oscillation is 2 pi rho h divided by rho Lg. Here rho is the density of the liquid and h is the height of the cork, and rho L is the density of liquid and g is the acceleration due to gravity. Here rho is the density of the cork. Now let us assume that initially when the cork is under equilibrium, it is submerged under the height of h naught, that is h naught portion of the cork is under liquid and rest is outside. So we will find out the force of buoyancy that is in equilibrium with the force of gravitation of the cork, because let us assume that this is the cork, so force of buoyancy will be in the upward direction and weight will be in the downward direction, which is initially in equilibrium, then Fb equal to W. Then we will find out force of buoyancy. Here force of buoyancy is equals to the volume of water, the weight of the volume of water displaced. Now volume of water displaced would be equal to the volume that is inside the liquid, so that would be equal to A into h naught. A is the base area of the cork and h naught is the height. So when we multiply, we will get the volume that is inside the liquid, and we will multiply it with the density of the liquid, so we will get the mass of the liquid that it displaces, and when we multiply it with the gravitational acceleration, then we will get the force of buoyancy. Now weight of the cork would be equal to rho times A, h and g. Ah is the volume of the cork and rho is the density of the cork. So density multiplied with the volume would be mass, and this is the gravitational acceleration, so this would equal the force of buoyancy. So we get the height at which the cork is submerged such that it is in equilibrium, so h naught would be equal to rho by rho L multiplied by h. So this is the depth under which the cork is there such that it is in equilibrium. Now when we will press it little more, so more liquid will be displaced, so that the buoyancy force will increase and the weight will remain same of the cork. So when we give a displacement of x, so the change in buoyancy force would be the rho of liquid would be same and the volume of displaced water would increase. So the volume of displaced water would be equal to a base area multiplied by initial height of equilibrium plus the submerged height. So it would be equal to A multiplied by h naught plus x. So this would be the new force of buoyancy under the pressed condition. Now when we release this extra pressure, then the difference between the new buoyancy force and the weight will act as a restoring force to bring the cork in the equilibrium. Now that would be equal to Fb dash minus W. Fb dash was the new buoyancy force. Now when we simplify it, we will get at rho L, that is the rho of density of the liquid multiplied by base area of the cork multiplied by the extra submerged height with the gravitational acceleration. Now so this is the restoring force that we have got. So this force will be responsible for causing the SHM. So by Newton's law, we know that force equals to mass times acceleration, and acceleration can be written as double derivative of x by with respect to time. So the mass of the cork can be found out using density of the cork multiplied by base area of the cork multiplied by the height of the original height of the cork. So that would be contributing to mass, and this is the acceleration. So mass times acceleration is the force, and we have got the restoring force equals to the density of liquid multiplied by base area of the cork multiplied by x, that is the extra submerged height, and the g is the acceleration due to gravity. Now upon simplification we will get the equation in this form. So this is the differential form of simple harmonic motion. This is the d2x by dt2, and this is omega square x. This is termed as angular acceleration. So we can write this in general form as d2x by dt2 plus omega square x equal to 0. So this is the differential form of SHM. Now omega here is the angular frequency. Now when we equate with the angular frequency, then we get omega square would be equal to rho L multiplied by g divided by rho into h. Now when we find out time period using this term, then we get time period as 2 pi root under rho h by rho L g. Thank you.